because it's a super easy thing to review, I'm just going to start my recording right here. This is the top of page 3. So let's go ahead and just go to page 3. And we did a lot of this stuff, but I was having trouble with the equipment, so I want to just kind of review this stuff. Okay, I'll post a video for the first 2 pages sometime tomorrow. Okay, all right. Okay, so vertical line test. So what we said was if any vertical line passes through exactly 1 point, then the graph represents a function. If you can find a vertical line that goes through 2 or more points, the graph is not a function. Okay, real quick review on this. So what you're going to see on this is these are examples of functions, because every line that you can possibly draw, vertical line, is only going to go through 1 point. Okay, you don't have to really put those little lines on there. I'm just trying to demonstrate that is what it looks like when it passes the vertical line test. Only goes through 1 point. Okay, those are functions. These things here are not functions, and the reason they're not functions is you can find a vertical line that goes through 2 or more points. So notice this point right here, you can barely see it on the handout. That's the point 5, 2, and this is the point 5, -2. What happens is when you have a function, any given x value has to have exactly 1 y. If you have 2 or more y values for the same x, then it's not a function. So that fails the vertical line test. This one fails, this one fails, that one fails. All you got to do is find one vertical line that goes through 2 or more points, then it's not a function. Okay? Yeah, the vertical line's always just going to go straight up and down. We have what we call a horizontal line test, but we're not there at this point. Okay, so let's just kind of do some of these together. Real simple. This is one of the simplest things you learn all semester. Okay, look at example 5a. Will that pass or fail the vertical line test? It'll fail. It doesn't matter where you go. Here's one place right there. That's going through 2 points, so no, that's not a function. Okay. How about the next one, pass or fail? That's a pass. Everywhere you go, you're only going to touch the curve 1 time. So that is what a function looks like. Okay, real simple. Okay, how about the next one, C, pass or fail? That's a pass. Okay, every vertical line goes through 1 point. Don't worry about that dashed line. That doesn't really have anything to do with that. Okay, so that is a function. Okay, how about the next one? Well, that's definitely a no. See, right here, it goes through 3 points. There's a point right here where it goes through 2 points. So all you got to do is find one place where it fails the vertical line test. Okay? Students always thrive on this. They have no problem whatsoever learning this. Okay? That's my observation. Okay? Is everybody good? Okay? Okay? Now, let's just kind of do these together. I want to just kind of review this real quick because it's pretty simple to review. So let's look at number 10. Number 10, does this pass or fail the vertical line test? Yeah, that one is a function. It definitely passes the vertical line test. Okay, how about 11? That fails. Okay, so that's not a function. That fails the vertical line test. And how about number 12? That's a pass. Okay, you don't have to put all those vertical lines. You're just kind of doing that in your head. So that passes the vertical line test. Okay, and how about 13? That passes. Okay, every vertical line is going to go through 1 point, so that passes. And how about 14? That fails. Okay, that fails the vertical line test. So that's not a function. And how about number 15, the last one? That fails also. Okay, so it fails the vertical line test. It's not going to be a function. Okay, does everybody feel okay with that? Okay, that's how you tell if a graph is a function. Okay, so one more thing that I had you do last class, then we'll kind of start the things that we didn't have time to do last class. One thing that you want to make sure that you know how to do from your background is how to plot points. So we're going to plot these points on here. So like this point right here, the x value is this way. It's left and right. X is a measure of left and right. Y is a measure of up and down. So if you start from the center, we call this point right here the origin. that point right there. The origin is just the 0.00. So you would go to the left 4 on the x-axis, then you would go up 5 on the y-axis. That's where that dot is, so just put a letter A by that. Okay, so all you're really doing is you're 4 on x, you're 5 on y. Okay, this system was not invented until the 1600s by Rene Descartes, and this system revolutionized the world. I mean, it revolutionized mathematics. We didn't develop calculus until this system was developed. And really, your television, any screen is all based on this idea. What happens on a television, seriously, is a bunch of information is sent in electrical signals, and it might have this information. It may say at the 0.77 on your TV screen, turn it on, turn that pixel on blue. All that information, these high definition televisions we have in this day and age have like thousands and thousands of pixels. The fact that the computers are so fast can at every instant of time just turn all those pixels on in the right color. And that's literally what happens. That's the information that's coming into your satellite and everything, or your cable. That's what that is. So it revolutionized the world. Okay, so next one, -3, 0. Again, just go to -3 on the x-axis, and then 0 on the y, so that point would be there. Okay, next one would be -4 on the x, and then -5 on the y. So that would be located there. Okay, and then 0, 0 is the origin, so that's there. And then E, you would go left 3, up 3. So that's where that's located. And then 1, 4, you would be going to the right 1, up 4. So that's where that's located. And then finally, the last point would be over 2 on X, up 4 on Y. That's where that goes. So one thing that we're going to start, into next week and stuff, we'll be doing a lot of graphing as we're learning this. So knowing how to plot points is fundamental from your background. Now, does this thing fail or pass the vertical line test? Pass or fail? Fail. Yeah, it fails here because of that vertical line right there goes through 2 points. It also seems like it fails there. So this is not a function. A graph doesn't have to be, the dots don't have to be connected. You could just have a series of dots. That's just not a function because basically what happens is this x value has 2 different y values. That's what causes that to not be a function. Every x value has to only have 1 y in order for it to be a function. Okay. All right. Any questions? Okay. All right. So that's usually pretty simple for students. Okay. This chapter 3 stuff you won't be tested on until the second test, but I'm just trying to give you more time to prepare for next week's test. So that's why we're going over some of this chapter 3 stuff. The next thing we're going to look at is evaluating a function. You may have done this in your background. I don't know. It just depends on what you've studied. So typically we write a function like this, f and then parentheses x, g, x, hx, and we say like f of x. If you had f and then t, you would say f of t and so forth. So that f stands for a function. We usually use f, g, and h to represent functions. We can use any letter we want to, but those are the most common things that you're going to see. So if you evaluate a function, all you really do is just plug in that given value for the variable. You're actually finding a point on the graph. So what we're going to do on this example 1a, we're asked to find f of -2. The function is x squared minus 3x plus 1. What I recommend that you learn how to do when you evaluate a function, everywhere you see an x, replace it with a parenthesis. I strongly recommend you learn how to do it that way so you don't make common mistakes. Then all you're doing is you're simply just plugging that in, then you're working out arithmetic, okay? So that's what we're going to do is do that, okay? So now we just work it out. What's -2 to the second? +4, -2 times -2. What is -3 times -2? +6. So see, just realize that that's a positive number, and since it's positive, put an addition sign there. That's the best way to learn that, to me, is like that. Okay, so the answer would be 11. So that's your answer to your problem. And what that means is, the meaning of that is, it just means that the point -2, 11 is on the graph. Okay, that's all that means. When you're evaluating a function, you're finding a point on the graph. That's literally what that means. So it's basically arithmetic. Okay? Okay, all right, let's look at this next situation here. Okay, this time we're doing g of t. So this time, again, just plug it in. You could use your calculator if you had decimals. So if you do g of -0.25, you're going to have, and again, I'm going to set it up kind of like this. And then I'm just going to pop in that value of t. That's what t is equal to, like that. Okay? Now, you can do this in your calculator. You know, as you're doing these, it's okay to use your calculator, particularly if you get decimals and stuff on this. So I'm just going to do this like this. I'm going to take parentheses -0.25 to the second. Those parentheses are important because that's going to give you a positive number. So what you're going to have from here, basically, when you do this now, is you're going to end up with 6 times 0.0625. Now this part right here, you have two negatives. Negative times negative is positive. If you need to use a calculator, you can, but you can do this in your head. What are 4/4 worth? $1, right? Okay, 0.25 times 4 is going to be 1. So you have that. Okay, now if you want to do this all in one step on your calculator, you're more than welcome to do that. You got 6 times 0.0625, like that, plus 1 plus 6, of course, which is 7. So that would end up giving the answer 7.375. Okay, and mathematically what that means is, it means this. It means that the point -0.25, comma, 7.375, that point is on the graph of this function. We're eventually, here in a few weeks, going to learn how to start doing graphs with and without a calculator. So that's the idea. Okay, so keep it simple. You're plugging in the number and you're doing arithmetic. And that arithmetic, you got to follow order of operations. Okay? Okay, let's move to this next page here and just do a couple more, then I'll let you finish up with just some problems here. Okay, then we'll start the next section. Okay, so this one goes like this. So again, you're doing h of z, so you're doing h of -8. So everywhere you see a z, you're going to plug in -8. So you're going to have, and again, I like to get students trained to use parentheses. I mean, you don't have to, but there sure is a benefit to doing that. Okay, like that. All right, what's the numerator? -16. What's the denominator? 0. So what's the answer? You can't divide by 0, right? So the answer is, we don't say no solution, we say it's undefined. Okay, so when h is -8, there's no point on the graph. That's what that means. And once we learn how to do graphing and stuff, you're going to know what's happening, you know, in several weeks, what's happening when x is -8 on that problem. Okay, so that's the idea. You can't divide by 0. Okay, the next one, now sometimes students on these last two problems struggle with this, but again, the idea is simply replace all of these x's with a set of parentheses. Okay, that's the easy way to do that. And everywhere you see an x, replace it with -x. Okay, it's the same idea. It's the -x that pops in like that. Okay, now you have to know about order of operations. You have to do exponents before you do anything else, right? And you can do stuff on scratch paper if you need to. If you're doing -x to the third, that means -x times -x times -x. So what happens if you multiply 3 negatives? Still negative, okay? And that would be x to the third. So you have to process that, okay? All right? Bring the -3 down. We're not ready to do anything with that. If you do -x to the second, what's a negative times a negative? It's a positive. So that would be positive x squared. You don't really need the parentheses anymore, okay? Now this part right here, you have subtract a negative. That's the same thing as two negatives being multiplied, really. So that is plus x, then plus 7. So that right there would be your answer to that problem. Okay, that's all you got to do. Okay, so it's plugging in that value when you evaluate. Okay, are we okay? Okay, this kind of stuff in this section is going to be easier for you than like 7.4 and absolute value. It's going to start easier. Okay, but it'll get more complex once we get into the graphing. Okay, one last situation on E is you're doing -3, and that means -3 times G of A. We don't put the time symbol there because that's part of the language, is a number in front of a variable is representing multiplication. So again, what I'm going to do is I'm going to bring down the -3 like that, and then I'm going to draw a bracket, and then I'm going to plug in to that function. So that function is saying 6 times something to the fourth minus 4 times something to the second plus 1. Okay, that -3 just drags down to the next stage of the problem. So what you're doing is everywhere you see a t in that function, you're simply going to replace that with a. So that's how that one gets put together. Okay, so I drop the -3 down, then I replace all of the t's with a, and now I got to work this out. So what you end up getting here is you would end up getting -3 times 6a to the fourth minus 4a to the second plus 1. It's actually okay to leave the answer that way. There's nothing wrong with leaving the answer that way. But what's the other thing you could do? Just do a distributive property. So I'm going to go ahead and do that. So if I do -3 times 6a, that's -18a to the fourth, and then plus 12a to the second, and then minus 3. Okay, so that would be a good way to write that. Final answer would be like that. Okay, so that's evaluating a function. That -3 is distributing, and see, that's changing those signs because you're multiplying by -3. Okay, is there any question on that? Okay, well, let's go down and let's work these last set of steps, these problems out yourself. So I think there is 7 problems, and I want to see what you can figure out on 7 and 6 and 7. I want to just kind of throw those out at you and see what you think about those. So go ahead and start on those last problems at the bottom of the page, and then we'll I'll give the next handout here while you're all working on it. And you can compare answers if you want to on these. I'm sorry. Okay. Okay. All right. Okay. You know what to do to stay ahead. Okay. You know to view videos and everything. Oh, okay. let me check you just on the first three. I'm just curious. What did we getting on number one? 19. Number one's 19. What did you get on number two? Undefined. That's good. What did you get on number three? Undefined. It's 0 over 0, but you can't divide by 0. On number three, when you plug that -2 in, you'll get 0 over 0. So it's still undefined. Okay. So 19 is number one. Number two is undefined. 3 is undefined. Okay. I do want to just kind of lead you to something on the last two and just kind of get you started. So when you're doing this number 6, the 7 plugs in there. So you're going to have 7 equals x to the third minus 1. Then you're going to solve that equation. Now that is an equation that we've learned how to solve. The number 7, you're going to do the same thing. You're going to replace g of x with 10. Then you're going to solve that equation, which is quadratic. So we've learned how to solve a quadratic equation. Okay, so I want to just kind of see what you all get on those. I'll give you a little bit more time to work through these things, a couple more minutes. Okay, and they start out real simple. So if you're doing f of 8, all you're doing is plugging that 8 in. So you're doing 3 times 8 minus 5. So that's 24 minus 5. So that is equal to 19. Okay, that's what all you're doing on the first 3 problems is plugging in. Same thing on the next one, just simply plug in. You're going to have 2 times -2 minus 5 over -2 plus 2. Now, if you see that that's a 0 denominator, then you can stop the problem, right? It doesn't matter that the numerator is going to give -9. So this one is undefined. So if you divide by 0, that means that if t is -2, then you have no answer to the function. Okay, so that's how that goes. Okay, right. The next one's the same idea. Just replace all the z's with -2. So h of -2 would be found by doing -2 plus 2 over -2 squared minus 4. That would give 0 in the numerator over 4 minus 4, or 0 in the denominator. So that one is also undefined. Okay, does anybody have any problem with the first 3? Those are arithmetic problems, okay? Same thing happens on the next one. Everywhere you see an x, you're simply going to change all those x's to a, okay? And you can do this one in your head. You just have 8 times a to the 5th minus 9 times a to the 4th plus a minus 5. Okay, now you don't have to write it with those parentheses. The best way to write this answer is just simply 8a to the 5th minus 9a to the 4th plus a minus 5. Okay, that's what you should have come up with on that one. That's just really changing a variable. That's all that we're doing with that. Okay, are we okay so far? Okay, now the next one, you're going to do -2, and then we're going to replace all of the x's with z. So you're going to have 8 z to the 5th minus 9 z to the 4th plus a minus 5, like that. Okay, now if you stop there, it's actually okay. That is a valid answer to that problem. I think what most of you did, and what you really ought to do, is just distribute to get -16 z to the 5th, and then plus 18 z to the 4th. Make sure your signs are okay. Then -2 times a is -2a, and then finally -2 times -5 is plus 10. So that's the answer that we'd be looking for on that. Okay, all right. Now don't let those number 4 and 5 bother you. All you're doing is changing the variable. That's it. What's that? Yes, why I decided to put an A, I have no idea. Okay, I guess I didn't change it is what I didn't do. Thank you for pointing that out. So yeah, that would be -2z. Now there's your answer. Okay, all right, is everybody okay? Okay, now when you do this situation, again, they're telling you what f of x is. F of x is 7, so this gets replaced with 7. Now you got to solve this equation. Does this look like something you've learned how to solve this semester? Yeah, what do you do to both sides? add 1. You got to isolate the variable, so you're going to have 8 equals x to the third. How do you make the x to the third turn into an x to the first? You do the third root of both sides. Okay, that's something we've learned to do. So that's going to be x. The third root of 8 is 2. Okay, because 2 times 2 times 2 is 8. So that's how you solve that one. Okay, I think most of you are doing good on that. Same thing happens on number 7. Go ahead and just plug that in. You got this equation. This is quadratic. How do you know it's quadratic? It's got a second power in it. The highest power is second power. So if it's quadratic, one side has to be set equal to 0. That's always your goal. So if you subtract 10 from both sides, you're going to have 0 equals 3x squared plus 20x minus 7. Okay, almost everybody did the quadratic formula. You got to work on your factoring so you don't have to keep doing that. I'm not kidding. Okay, so here's how we're going to factor this. This one did factor. The first term, what are you going to use to get a 3x squared? 3x and x. I know you can do that. There's no problem doing that. I know you can do that. How about for the 7? That's the last term. What are you going to use? 1 times 7. Okay, now the order is going to make a difference on that. So I'm going to put a 1 and a 7 there. When you learn to factor by trial and error, you have to write something on your paper. Now, that inside term is 1x. That outside term, 3 times 7 is 21x. What are you trying to do with that inner and outer term? What are you trying to make happen? You're trying to make this add up to positive 20x. See, you can't process this in your head. Okay, so you tell me, how do you make 1 and 21 add up to positive 20? You have a negative and a positive. So when you do trial and error factoring, write on your paper. You can't do it in your head. Okay, you have to write something on your paper. So what'll happen then is the negative will go there and then the positive will go there. Did anybody factor this in this class? All right, you did in the back. Anybody else? You did. Very good. You don't have to, but it is faster, isn't it? It is ultimately faster than the quadratic formula. So now you set each factor equal to 0, and then you're going to get what x is, okay? So this would be add 1 to both sides. You get 3x equals 1. So you would end up getting 1/3 would be one answer. Okay, and then over here, you can do this one in your head if you want to. That's x equals -7. That's your second answer. That's it. If you did the quadratic formula, it would have worked out to give the same answers. Just more work.
When you add that 3 in front of the x squared, it makes it feel more intimidating.
It does. And what happens is if you have something like, if you had x squared plus, let's say 20x plus, it's hard to make these up sometimes, but let me show you something. If you had something like this, when you have nothing in front of x, it's easier. You can do this in your head. Because when there's nothing in front of x, then the question just becomes, what two numbers multiply to give 24 that are going to add up to 8? Now, I think I made a bad problem on that. Let me put an 11 there, okay? What two numbers multiply to give 24 that add up to 11? 8 and 3. So you can do that in your head. But once I put a number right here, you can't do it in your head anymore, okay? So don't think of it as intimidating. Just think of it as I need to play with it a little bit, okay? All right, how'd we do? I think we did pretty dang good. Okay, very good. That'll end up that section. So let's go ahead and take our break here. I'll give you till around 1:30, okay? And then we'll start on the 3.2. And then I'll post this recording probably after class.